Hi and welcome to another very exciting tutorial. In this video we're going to build a cool pairs game that works in augmented reality. We're going to do that from scratch, building our own cards and using some models from the Apple AR Quick Look Gallery. Before we get started, I'd like to give you a quick 1-minute look at my new Udemy course about Swift UI. You can get that course for just $9.99 for the next 4 days. Just click on the link in the video description below. With Swift UI, you will build better apps with less code. It makes app development a lot faster, simpler, and even works across all Apple platforms. Swift UI gives you automatic support for dynamic type, dark mode, localization, and a lot more. I am Brian Advent, and I've been working as a developer and trainer, especially in the Apple ecosystem, for almost a decade now. This course wants to bring you beyond the standard tutorials of displaying some local or web-based data in a list. It wants to address the questions that arise when creating an app with Swift UI for the first time and cover topics that will enable you to understand app development with this new toolset and thus make you feel comfortable continue the journey of exploring Swift UI on your own. I'm going to provide you with all the knowledge you need to create your own Swift UI apps in no time. In our sample project, we'll build a cool user interface, use UIKit classes like the map view and Swift UI. We are going to explore the most important property wrappers that are mostly responsible for the reactive magic of Swift UI. We're also going to create custom shapes, animate them, store data, and so much more. Building this app from start to finish will give you a head start when working on your own projects with Swift UI. To get the most out of this course, you should have a solid knowledge about Swift 5, and you should also know your way around Xcode. Please feel free to take a look around the course description and have a look at the preview videos. I'd be very happy to see you inside. So if you want to get started with Swift UI, be sure to check out the link in the video description below. And now let's get started from scratch by creating an augmented reality app right here in Xcode. I'm going to call it Pairs AR. And for the content technology, we're going to use RealityKit, not SceneKit, not SpriteKit, but RealityKit. Great features. We're going to see how they work in a second. And for the user interface technology, we're still going to rely on Storyboard for now and UIKit because it's still better supported, and we would have to create UI view representables in Swift UI. All the same, so still going with Storyboard. Good choice for now. I'm going to create that on my desktop. Now, what we should do first, and what we can do in our case, is we can get rid of our experience.rc project file. We won't need that since we're not going to work with the Reality Composer for now. And what we can also do now is just open up our view controller and just delete everything that is related to this reality file and the experience from Reality Composer. And now we really work with just a plain simple view controller that we have in our storyboard. In our storyboard, we have an AR view, and this is the one that we have as an outlet right here in our view controller class. Nonetheless, we're going to start in view to load, and we need something to actually tether our virtual content to in the real world. Therefore, we're going to use an anchor, and this anchor is created using an anchor entity. We are going to initialize that with a horizontal plane and not a vertical. We're not playing on a wall. And we also can define some minimum bounds within an array. I'm going to go with about 20 centimeters for a square playing field, at least. This is the minimum that we want to define. And then what we need to do is using our AR view. This view contains a scene that renders and simulates everything. And here we want to add our anchor that later tethers our virtual content to the real world. So this is where we add our anchor. And now that we have that, we want to place some of our playing cards on our playing field. And just to illustrate that a little bit better, what we've done so far, let me show you this graphic real quickly. So what we have is our AR view. We have that in our storyboard, in our view controller. And in this AR view, there is a scene that, as I said, renders everything. And we place anchor entities into the scene, or we add these anchor entities to our scene, and there can be multiple of these anchor entities, and then we add entities to these anchors. These entities are our virtual content. In our case, these are our cards and our models. And RealityKit defines a few concrete subclasses of entity that provide common use functionality. For example, our anchor entity is one of these subclasses, and then there is also the model entity that we're going to use to represent a physical object in our scene. So what we need to do here now is to define an array of entities, because we want to have multiple cards. This is just going to be a lot simpler working that way. And now to start with, we're going to start with 4 cards. So let's use a for loop to create just 4 cards. And our cards are actually going to be very small boxes. So let me create a box constant here. And first of all, to define such a box, we need to create a mesh for this box. And we're going to use mesh resource and use the generate box function here. But we're not going to go with a size, since we will have different lengths for each side. We're going to go with a width of about 4 centimeters and also a depth of 4 centimeters so that we get nice square cards. But we're going to go with a height of about 2 millimeters only. This, you can experiment with that. I just thought this looks quite nice. So we're going to go with a depth and a width of 0.04 meters, so 4 centimeters in each direction. And this is going to be the shape of our card, or our mesh. And what we also need is a material. We're going to use a metal material for our boxes. So we're going to initialize that with a simple material with a color. In this case, I'm going to go with gray, and I want this to look a little bit metallic so that we get nice reflections. And the last step is to actually create the model itself, and therefore we are now going to use the model entity, and we can provide that with a mesh. This is going to be our box, and within an array we're going to provide our materials, or our one material that we have, our metal material. And that's actually all there is to it. Now later we want the ability to press on these boxes or on these cards. So what we're going to do is use the model, and we directly generate collision shapes so that we can actually touch these objects. And I'm going to set this recursive option to true here. And this is actually all there is to create such a card. Now we have our cards array that is still empty. So let's now use it and just append our models each time we iterate through this loop. Now we can't see anything, and we still need to position our cards. And we're going to do this again in a for loop. That's very simple. We're going to need an index for that. We're going to need our cards for that. And we're using a for in loop here again, using our cards enumerated. And this gives us a sequence of pairs. We get our index for each card, and we get the card itself in this loop. And to create an x coordinate, what I'm going to do is, using my index modulo 2. We're going to increase that to 4 later so that we have a bigger playing field. For now, with our 4 cards, so that'll do. I'm going to cast that to a float, since when we're positioning our cards, we need to work with float as a data type. And the reason why we're using the modulo operation here, let me just quickly outline why. Maybe plotting a table here using modulo and and using from n equals 0 to 3. And if we have a look at this plot, then, as you can see, when we're performing 0 or index 0 modulo 2, we're reaching 0, of course. If we have 1 modulo 2, then we're getting 1, which means that, speaking about the x coordinate, the first card is going to be placed at x position 0. The second is again going to be positioned at 1. The third, since 3 modulo 2 is 0 again, is going to be placed at 0, so that we always get this positioning of our cards that we want. And then for the fourth card, of course, at index 3, 3 modulo 2 again is 1, so again placed in the second column. I hope that makes sense. Maybe if you just think about that again for a second, it becomes clear what we are doing here. And for the z coordinates, this is a lot more simple here. We just use, again, a float, use index, divide that by 2 in this case. And now we can position our card, and as you can see, this requires a float value here, or actually a matrix with float values. So to actually, for this to make sense, we're having rather large numbers here, 0 and 1, which would be a meter. And we just want to scale that down a little bit. So we're going to use, for the x value, we're going to just multiply that with 0.1. We don't want to move that in the y direction, and in z direction, again, just scale that down a little bit by multiplying it with 0.1. And actually, that's all we need to do. Now we can use our anchor and add our child, which is our card, and have a look at that on a real device. Now, what I didn't mention earlier, and that could be a problem, if you are trying to actually just initialize the anchor entity, if you do not have selected a generic iOS device or a real device, then you simply cannot use this function and initialize it, or use the plain initializer. Just make sure that you have selected the generic iOS device or a real device as a target for simulation. So having this on a table plane surface, we get our 4 cards. They have this nice metallic look, and this is what we have created so far. Let's now move on and actually make it possible for us to tap on our cards and rotate them. And therefore, I'm going to go into our storyboard, pressing Command-Shift-L to get our object library. And what I want is a tab gesture recognizer, which I'm just going to drag on my AR view right here. And to work with that in code, I'm going to bring up an assistant editor right next to it, switching to my view controller, and right below my view.load function, I'm going to create an IB action for the tap gesture recognizer. So I'm pressing Control, my keyboard, clicking on my tap gesture recognizer, and just dragging right below this closing curly brace right here, and making sure that my connection is set to a action, and I'm going to call this on tap, and for the type, I'm going to select UI tap gesture recognizer. Let's connect that. And that's actually all there is to do for us in the view controller. We can close down the assistant view and go down to our IB action. And in this action, what we need to figure out is the location on which we tapped actually a location where also a card is located. Therefore, we need to get the tap location. This is actually part of the sender object, so we can use sender and its location, and we want the tap location in AR view. And AR view has a nice little function. Let's use AR view and entity at point, and we're looking for the tap location point. And we can now actually get back an entity right here. So we're checking with an if-let statement using a card object here to assign our entity to. If this works, then we're sure that there is actually a card that we can work with. And now, if the card is already turned around so that we can see our object, then we want to just flip it down again. So this is the first step that we're going to think about. So we're checking the card, its transform, its rotation, and its angle. And if that is equal to pi, then we have a 180-degree rotation. Then we actually want to flip it down. To do that, we're going to create a flip down transform object right here, and we're going to start with the current transform that our card already has. And now to actually make the rotation possible, we can use some very powerful and very low energy calculations. So using rotation, you can see that we should use an SIMD quad F, which is SIMD stands for single instruction multiple data, which means that we're actually performing the same operation on multiple data points simultaneously in a matrix, for example. And a quad stands for quaternion, and quaternions have the advantage over matrices have advantages over matrices when representing rotations, since they're greatly simplifying the interpolation between rotated coordinates. So this is the reason why Apple uses this format here, and we just have to work with that here. So SIMD, quaternion as a float, and we're going to use an angle and an axis here. So we're resetting it to an angle of 0, because we have already checked, is our rotation equal to pi? So 180-degree rotation, and we're interested in a rotation around the x-axis. So we're setting x to 1, y to 0, and z also to 0 within an array, just to explain what we are doing here. So very simple rotation that we're applying here, and now we're using the card and using the move function to actually also get this animated. We're moving it to our flip down transform, and this is actually wrong. We're not interested in the axis here, we're interested in the angle. If the card and its transform and its rotation and its angle is equal to pi, rotation by 180 degrees, then we do what we do here. So the card should be moved to its flip down transform. This is relative to the card and its parent. The duration, let's say this animation should take about 0.25 seconds, and I want this to ease in out to have a smooth and cool looking animation. And in any other case, which means that we do not have a rotation yet for our card, we actually want to rotate it by 180 degrees. So we're going to create a flip up transform, same game in another direction. So we have our card, take our transform. We actually want to change the rotation using our quaternion here, SIMD, quaternion F, and we are interested in the angle. Change it to pi, which is a 180-degree rotation. And again, we're rotating around the x-axis, set both other axes to 0. And then we can just use the same thing, card, move, this time to the flip up transform, relative to card parent, our duration 0.25 seconds, and ease in out animation. That's it. Let's run it and see how this looks when we actually rotate our cards on our playing field. So here we have our cards. I'm pressing on these cards and we can see the rotation, also rotating them back. So this works quite nicely and we can interact with our game for the first time. Cool. Now this actually was the hardest part. Now what we're going to do is actually just loading our models and place them on these cards. And I have just downloaded some of the models from the Apple AR gallery. You will find some of these USDZ files right there, like this plane or this flower pot. And this is actually from Adobe Aero. I've just exported this hashtag from Adobe Aero as a USDZ file, just as this tree. So you can work with whatever you actually like. If you want to recreate something like that, of course, you will also find all these models in the tutorial files below. And I'm going to just drag and drop them into my project. Right below my main storyboard. I make sure that copy items if needed and add to targets pairs AR is selected. And just to keep build times very fast, I'm going to just use the first two objects later. We are going to upgrade this to 8. This is also why we're just working with 4 cards at the moment, working with 2 of these objects. And I'm going to show you how to really efficiently load them right now. So in our view.load function, we could also put this in a specific function, but for this tutorial it'll do. In line 42, after we have positioned our cards, I just want to load my first model. So this is going to be a model entity, and I can load a model synchronously and asynchronously. Since we are going to load, or we are about to load 8 models, we should definitely load the model asynchronously. And we just have to supply this with a file name, or with the name of the model, in our case 01. And now this gives us a result. We should assign this to something. And load model asynchronously returns a load request, which works actually like a publisher in Combine. And to make this really efficient, we're also going to use the Combine framework. So let's quickly import Combine into this file. And we're going to start by actually assigning that to a so-called cancelable. So let's define a cancelable, which is going to be of type any cancelable, optional, and just initialize this with nil. And this ensures that the load request that we're using right here, this load model asynchronously, is not deallocated until we no longer need it. So without this, our load request would cancel before our assets are loaded. So we're just going to use this cancelable object right here and assign the result of this model. Now, this is not the only model that we actually want, and as you can see, we cannot assign a value of type load request to this any cancelable. And this is because what we are later going to give this cancelable is a closure. But for this to work, and you see that there is more to just loading this one model right now, we're actually going to load more. So what we're going to do is append more elements. And this is going to be another model entity, of course, and we're going to load this asynchronously. And this is going to be our model 2. We're later going to add 3 through 8. And then we're going to use the collect function, which actually collects all received elements, emits a single array of the collection, and then do this when the upstream publisher finishes. This is what this collect function does. So we now have all of our elements, and we're now, and this is what's the cancelable, actually once we want to actually give that its closure that it can work with by using the sync function. And sync now gives us a subscriber to our load requests and allows us to use a closure that runs when the asset has loaded. So we get a receive completion and we get a receive value that we want to work with. And in this completion, there is the possibility for getting an error object. And this is where we could, for example, print an error, unexpected error actually, maybe it couldn't load or whatever. And then we can use our cancelable and cancel what's just happening. And this means that we're stopping any side effects or anything that's currently running related to that. And as for the receive value here, we're getting all the entities that are loaded. So we can get the entities in this function. Now let me just quickly see if I did this right. So here we cancel that. And then, okay, we have our entities, and there is the closure. All right, so now we can work with our entities. And what we want to do is, first of all, maybe scale them down, generate collision shapes, and then actually clone them, because we need each entity 2 times. And we're going to do this efficiently as well. So first of all, let's create an array of objects, which are going to be model entities, and initialize that with an empty array. Now, next step is going to be to scale down all of our entities. So we're going to use a for loop here, using entity in entities, and using each entity and call the set scale function right here again. And again, this is an SIMD function, so we're working on multiple data points simultaneously. So we're using SIMD 3 with a type of float, and scaling that to 0.002 for X, Y, and Z. And if you're working with different models, this could actually vary, and you just need to try out what works best in your case, and this is relative to our anchor. And with this scale done, we can also use these entities and generate collision shapes again, so that we can also press on the objects like the plane or the flower pot and so on. And what we also want to do now is to clone each entity, because we're playing pairs. We need a pair of each of these models. So using a for loop again here, and just applying this here, using our objects array right now, and just append. And now we're using the entity and its clone function again, using this recursive flag, setting this to true. And this is a lot more efficient that way, since we're using this RealityKit clone function. And the reason why we added that to this objects array is actually to be able to now shuffle our objects so that the pairs aren't right next to each other. So I can just use the shuffle function for a collection right here. And all that is left to do now is actually to place these elements on our cards. So again, a for loop is what we need here, again with an index and each of these objects. We're again using objects enumerated to actually get the index and the object itself. And what we need now are our cards. We're now accessing each of these cards with our index, and then just add a child, which is the object. And with that done, we can actually have a look at our game already and see how this works. And if we have a look at that, you can see that it is actually looking quite nice already, but there is a little bit of a problem, or multiple problems actually. We can rotate these elements and press on these elements, and everything works nicely, but we can see our models right when we launch our game, and this actually works quite nicely. We can look at everything, but we shouldn't see them when we start the game, and we also shouldn't see them when we rotate our cards. So let's also quickly fix that. And one easy fix for actually placing our models below the card is actually just to rotate the card. We also know how this works. We're taking each card by using the index use transform, use rotation, and then simply apply such a rotation using SIMD quad F, and then using an angle of pi around the x-axis, just as we already did before. And since I think we're now done here, we should also make sure now to actually take our cancelable and also cancel the activity to stop any side effects and so on from happening. And with that, we have solved problem 1. Problem 2, that we can see the models right below our card. Therefore, we need a slightly different fix. And we're going to apply that right before we're actually loading our models. So after we've created our cards, just in line 42, 43, we're going to create an occlusion box, and that's really simple. We're just defining a box size first, so let me just quickly do that. It's going to be a float. I'm just going to make this a little bit larger. 0.7 means almost a meter, 70 centimeters. This should give us enough space for later as well. And then we're going to create an occlusion box mesh, just as we did before with our cards. And this time, since we just can generate a cube here, I'm going to just initialize that with a size and the box size. And now the magic happens by actually applying a occlusion material that hides everything beneath it so that it is not going to be rendered and we don't really see it. And we're going to create that by just creating now an occlusion box using a model entity for our mesh. We are going to use our occlusion box mesh for the material passing along an array, and here we're just going to initialize an occlusion material object, and that's doing all the magic for us. Now we still need to position it correctly, so we're using the occlusion box now, position it along the y-axis, and just using half the box size negative way. And then we can actually just use our anchor, add the child occlusion box, and if we run this now, we should have a very good result. And indeed, if we have a look at our game playing field, we don't see our objects. Now, if I press on one of the cards, yes, that's great. We're rotating the card, and I found my first matching pair. So here is the second pair. We can rotate them back. So that's cool. And that's just what we wanted. Now, all that's left to do is actually increasing the number of cards, or actually the models, and then we're actually done. So let's move on. And we really don't need to change much. We already have imported all of our models. What we need to do now is to create more cards. I actually want to have 16 cards. We then want a 4x4 playing field, so 4 cards in each direction. So we're changing also our calculation here a little bit. Besides from that, we're good to go. And then all that's left to do is actually load more cards. And therefore, we just have to copy line 56 and just do this quite a few times. So we have, we can load object 3, 4, 5, 6, 7, 8. And that's all there is to it. Now we can run this again and see our game in action. And what I got as a result looks like this. I just recorded this on a little bigger surface so that we can see all of our elements. So we have now 16 cards. We can flip the cards. I obviously didn't take the rules too seriously here, but it really looks cool with all of our nice models. And if you're taking your own models and personalize this, I think this is really a nice game. I did a little modification though, which is for the positioning. I moved everything a bit more to the left and up by just subtracting 1.5 for X and Z coordinate, so that it's centered a bit more. But that's it. That's our pairs game in augmented reality. I hope you had fun building this game. I hope it's useful for you. Don't forget to check out my new course on SwiftUI. Be sure to subscribe to this channel to not miss any new videos. And I thank you so much for watching. See you in the next one. Bye.